Hello guys, welcome to Code Enzyme, and in this video we are going to discuss the problem 980 of Leetcode, and the problem name is unique paths 3. So this is a hard problem, and let's read the problem statement. You are given an m cross n integer array grid where grid ij could be 1 representing the starting square. This is exactly one there is exactly one starting square, and 2 representing the ending square. There is exactly one ending square. 0 representing empty square which we can walk over, and -1 representing obstacles that we cannot walk over. We have to return the number of 4-dimensional walks from starting points to the ending square such that we walk over every non-obstacle square exactly once. So let's see, if we are on some ij block, then we can either go up, down, left or right. And we just have to make sure that it is not an obstacle square. It should not fall off the grid, and also we have to make sure that we have not walked this square before. So we can't just go to some square that we have already walked in the path. So these are the 3 conditions that we have to check, and we are good to go. So let's see examples first. The first example given is we have this square 4 cross 3 grid, and this is a start point, this is the ending point, and this is the obstacle. So we can try making some paths, and these are the only 2 paths which will be possible. All the other paths will either give you a path that does not cover all the square, or a path that does not lead to the finishing point. So we have to tackle these 2 cases also, and let's see the example number 2. In this case we don't have any obstacles, so we have 4 possible paths, and all the other paths will give you those 2 above cases. And in this third example we have only 2 possible paths, and none of them covers all the squares, so the output is 0. So just by looking at this problem and reading the problem statement, I can say that this is a depth first search problem, DFS, and we know that DFS can be implemented in one way is the iterative solution, another is the recursion plus backtracking. And recursion plus backtracking is simpler to code. The code is much shorter than the iterative one. So let's first see the iterative solution. So for this iterative solution, I can say that till this point I am setting these 3 variables. That is, I am finding the start point, finish point, and the obstacle point, and the number of obstacles. So if I find an obstacle, I will append it to the obstacle. If I find the start point, I will update this variable. If I find the finishing point, that is number 2, I am going to update this finishing variable. Now I have this stack, and in this stack I am going to find all the possible paths in this grid, even those paths that will not lead to the finishing point also. And this is the length of the path that we want, because there will be many paths that will lead from starting point to finish point, but those paths will not cover all the squares. So we have to make sure that the length is constant. So length will be the number of squares minus the length of obstacles. That should be the length of the path, otherwise we will not consider that path. So till my stack is empty. So till my stack is empty, I am going to pop the top element of the stack, and my current path will be equal to that element. Now my current square will be the last element of that current path, and if that current square is equal to finish, and if the length of the current path equal to the length, then I am going to say path plus equal to 1. Otherwise I'm taking the I and j coordinates, and now I am checking those 3 conditions that we discussed before. So I have to first check that the point does not fall off the grid, this point is not in the current path, and this point is not in the obstacle. If that is the case, I am going to append this current path plus that point in the stack. And these are the 3 cases. These are the 4 points that we need to check for. And after this while loop is over, I am going to return my paths variable, that is the number of paths that we get after this while loop. So I hope you were able to understand it. Let's see the recursion plus backtracking solution. and as you can see the code looks much simpler. So first I have NNM and len grid 0, and this is the count. It is the number of squares that are left to walk. So I am just counting the number of squares that we can walk over in this whole loop. And this is my DFS function, and I am using non-local count. What this means is, for those who have never seen this before, it means that we can use global count, but it will not consider this count. If you want to use global, we have to use this variable outside even this function. So I would have to write count equal to 0, then I have to specify global count equal to 0 here, and then I also have to specify global count, and then this code will work. And if I have to use something that some variable that is in the parent function, then I have to use non-local count. Okay, so let's see. And this result, it stores the number of ways from I, j to my finishing point. So currently it is 0, and now I have to check from the four ways that I can go, and if these 4 is in my range, then and if that square is 0, then I have to then I can set it as an obstacle first. So when I come back, I will see it as an obstacle and I will skip it, and I will decrease my count. So the number of squares that I have to walk is 1 less after I walked over this square, and result plus equal to DFS of that square. And I have to backtrack it, so I have to make these just like previous. Else elif, if this is my finishing point, then I have to check if my count is equal to 0, and if that is 0, then I will do result plus equal to 1, and this result when I return it from here, it will be returned in this from this here, and overall it will give me the final number of paths. And DFS, and we have to return DFS of starting point. We do not have to return a DFS of 0, 0. We have to return DFS of start 0 and start 1. So I hope I was able to explain you the recursive code properly. If you were able to understand it, kindly like this video, subscribe to my channel. I will see you guys next time with another problem. Thank you.